The absence of neutrals in one of the existing ones raises concerns about how the workshop lights are receiving a complete circuit. It's essential to understand where the neutral connection for these lights is actually located. The presence of hot current in only one direction on some of the runs can create inductive effects, potentially affecting other circuits or appliances in the vicinity. This is because alternating current flow in a conductor produces a magnetic field. When the current flows only in one direction for a significant time, it can induce currents in nearby conductors, which is generally undesirable. The unidentified switch and its associated wiring are a potential safety hazard if not properly identified and addressed. Without knowing what the circuit controls or how it's wired, there's a risk of electrical shock or fire. Remove all the existing wiring and replace it with new 14.3 non-metallic sheath cable. This will provide a proper and safe electrical circuit with identified neutrals and switch legs. This is the most comprehensive solution, ensuring that all wiring is up to code and properly grounded. The non-metallic sheath cable contains a black wire, a white wire, a red wire, and a bare ground wire, providing all the necessary conductors for modern wiring practices. Install a ground fault circuit interrupter, often called a GFCI. This device will trip if there is any leakage of current, providing additional protection against electrical hazards. A GFCI constantly monitors the current flowing into a circuit and compares it to the current flowing back. If there's a difference of as little as 5 milliamps, it will trip, cutting off the power and preventing electrical shock. Use a voltage tester or other diagnostic tool to locate the buried junction box or outlet where the mystery run connects. Identify its purpose and ensure it is properly wired. This involves systematically tracing the wires from the mystery switch to see where they lead. A voltage tester can help determine if the wires are energized, and a circuit tracer can help follow the wires through walls and ceilings. If tracing the mystery run is impractical, isolate it by disconnecting the switch that controls it. This will prevent it from posing a potential hazard. This involves simply disconnecting the wires from the switch and capping them off with wire connectors. This will prevent anyone from accidentally turning on the circuit and potentially causing a problem. It is not advisable to reconnect the old switches and ignore the potential issues. Ignoring these problems could lead to electrical shock, fire, or damage to appliances. The safest and most reliable solution is to rewire the circuit with new 14.3 non-metallic sheaths cable. This ensures that all wiring is up to code and properly grounded, eliminating potential hazards. If rewiring is not feasible, carefully assess the existing wiring, install a GFCI, and trace or isolate the mystery run to mitigate any potential risks. This involves a combination of safety measures and careful investigation to minimize the risks associated with the existing wiring. Consult with a qualified electrician if you are not comfortable with the electrical work involved. Electrical work can be dangerous, and it's always best to consult a professional if you're not sure what you're doing. This is a reminder to prioritize safety and seek expert help when needed. When dealing with older wiring, especially armored cable, understanding its construction and potential issues is critical. Armored cable, often referred to as AC cable, typically consists of insulated conductors wrapped in a flexible metallic sheath. While the metal sheath provides some protection against physical damage, it doesn't always provide a reliable grounding path. Over time, the connections within the sheath can corrode, reducing its effectiveness as a ground. Firstly, identify the age and condition of the armored cable. Although armored cable may have cloth insulation that can become brittle and crack, exposing the conductors. Inspect the cable for any signs of damage such as cuts, dents, or corrosion. Secondly, test the continuity of the metal sheath to ensure it provides a reliable grounding path. Use a multimeter to measure the resistance between the metal sheath and a known ground. A low resistance reading indicates good continuity, while a high resistance reading indicates a potential problem. Thirdly, carefully examine the connections at each end of the armored cable. Ensure that the connectors are properly tightened and that there are no signs of corrosion. If necessary, clean the connectors with a wire brush and apply a small amount of antioxidant compound to prevent future corrosion. When working with existing circuits, it's essential to identify all the conductors and their functions. This can be challenging, especially in older wiring systems where the color coding may not be consistent with modern standards. One common issue is the presence of white wires that are used as hot conductors. This can occur when a switch loop is wired using a two-conductor cable, where the white wire is used to carry the hot current from the switch back to the light fixture. To identify the function of a white wire, use a voltage tester to check if it is energized. If the wire is energized when the switch is on, it is likely being used as a hot conductor. In this case, it should be marked with black tape or permanent marker to indicate that it is not a neutral wire. Another common issue is the presence of ungrounded circuits. In older wiring systems, it was common to omit the grounding conductor, which can create a safety hazard. If you encounter an ungrounded circuit, it's important to take steps to improve the grounding. One option is to replace the existing receptacle with a ground fault circuit interrupter, often called a GFCI receptacle. A GFCI receptacle will protect against electrical shock by detecting any leakage of current and tripping the circuit. It's also important to ensure that all metal boxes and enclosures are properly grounded. This can be achieved by connecting a grounding conductor to the metal box and bonding it to the grounding system. When adding new circuits or modifying existing ones, it's important to comply with the National Electrical Code, often called the NEC. The NEC provides detailed requirements for wiring methods, conductor sizes, overcurrent protection, and grounding. Firstly, ensure that all conductors are properly sized for the load they will be carrying. The NEC specifies the minimum conductor size based on the ampacity of the circuit. Secondly, provide adequate overcurrent protection for each circuit. This can be achieved by installing circuit breakers or fuses with the appropriate amperage rating. Thirdly, properly ground all circuits and equipment. The NEC requires that all metal boxes, enclosures, and equipment be grounded to provide a safe path for fault current. When installing three-way switches, it's important to understand the wiring configuration. A three-way switch allows you to control a light fixture from two different locations. The three-way switch circuit consists of two three-way switches and a four-conductor cable running between them. The four-conductor cable contains a black wire, a white wire, a red wire, and a background wire. The black wire is used to carry the hot current from the power source to the first switch. The white wire is used as a neutral conductor and is connected to the neutral terminal on the light fixture. The red wire and the blue wire, if present, are used as traveler wires and are connected to the traveler terminals on the switches. When wiring a three-way switch, it's important to identify the common terminal on each switch. The common terminal is typically marked with a different color screw or a different shape. The hot wire from the power source is connected to the common terminal on the first switch. The traveler wires are connected to the traveler terminals on both switches. The light fixture is connected to the common terminal on the second switch. When troubleshooting electrical problems, it's important to follow a systematic approach. Firstly, identify the symptoms of the problem. What is not working correctly? Is there a burning smell or a buzzing sound? Secondly, gather information about the circuit. What is the circuit supposed to do? What devices are connected to the circuit? Thirdly, use a voltage tester to check for voltage at various points in the circuit. Is there voltage at the switch? Is there voltage at the light fixture? Fourthly, use a multimeter to check for continuity. Is there continuity between the neutral wire and ground? Is there continuity between the hot wire and the load? Fifthly, use a circuit tracer to follow the wires and identify any breaks or shorts. With the mystery run, consider the possibility of abandoned or unterminated wires within the walls. These can pose a shock hazard if they become energized. If the circuit cannot be identified and safely terminated, it is best to disconnect it at the source and ensure the wires are properly capped and insulated. Check for any signs of rodent damage to the wiring. Rodents can chew through insulation, exposing the conductors and creating a shock hazard. Look for droppings or gnaw marks near the wiring. If rodent damage is found, replace the damaged wiring and take steps to prevent further infestation. Also, inspect the electrical panel for any signs of loose connections or corrosion. Loose connections can cause overheating and potentially lead to a fire. Corroded connections can reduce the efficiency of the circuit and cause voltage drop. If loose or corroded connections are found, tighten or replace the connections as needed. It's important to use the proper tools and equipment when working with electricity. Always use insulated tools and wear safety glasses to protect your eyes. Use a voltage tester to verify that the circuit is de-energized before working on it. Use a multimeter to measure voltage, current, and resistance. Use a circuit tracer to follow wires and identify breaks or shorts. Before beginning any electrical work, disconnect the power to the circuit at the breaker panel. This will prevent electrical shock. Test the circuit with a voltage tester to verify that it is de-energized before touching any wires. If you are not comfortable working with electricity, hire a qualified electrician. Electrical work can be dangerous, and it's always best to err on the side of caution. When selecting replacement switches and receptacles, choose devices that are rated for the voltage and amperage of the circuit. Use tamper-resistant receptacles in areas where children are present. Use weather-resistant receptacles in outdoor locations. When installing wiring in walls or ceilings, follow the National Electrical Code requirements for cable support and protection. Secure the cable with cable staples or straps every few feet. Protect the cable from physical damage by routing it through conduit or using nail plates. When splicing wires, use wire connectors that are rated for the size and type of wire being spliced. Twist the wires together tightly and securely before installing the wire connector. Make sure the wire connector is properly sized for the number of wires being spliced. When running wires through metal studs or framing members, use grommets to protect the wires from abrasion. The grommets will prevent the sharp edges of the metal from cutting into the insulation of the wires. When working in damp or wet locations, use waterproof connectors and enclosures. This will prevent moisture from entering the electrical system and causing corrosion or short circuits. When installing recessed lighting fixtures, make sure the fixtures are rated for contact with insulation if they will be covered with insulation. This will prevent overheating and potentially starting a fire. Always follow the manufacturer's instructions when installing electrical equipment. The manufacturer's instructions will provide important information about the proper installation and operation of the equipment. Regularly inspect your electrical system for any signs of problems. Look for frayed wires, loose connections, or damaged components. If you find any problems, have them repaired by a qualified electrician. Keep electrical panels and equipment clear of obstructions. This will allow for easy access in case of an emergency. Do not overload electrical circuits. Overloading a circuit can cause overheating and potentially start a fire. Use a circuit analyzer to determine the load on a circuit and make sure it is within the safe limits. Be aware of the location of underground utilities before digging. Contact your local utility company to have them mark the location of underground utilities before you dig. This will prevent damage to underground utilities and potential injury. Educate yourself about electrical safety. The more you know about electricity, the safer you will be. Take a class on electrical safety or read books and articles about electricity. Teach your children about electrical safety. Show them how to use electrical equipment safely and warn them about the dangers of electricity. By following these safety tips, you can help prevent electrical accidents and injuries. In this specific scenario, with the older wiring and the mystery circuits, it is highly recommended to consult with a licensed and experienced electrician who can thoroughly evaluate the situation and provide the safest and most appropriate solution. A professional electrician will have the expertise and equipment to identify the unknown circuits, trace the wiring, and ensure that all electrical work is performed in accordance with the National Electrical Code. Remember that electrical work can be dangerous, and it's always best to prioritize safety.